So in this case we have two limits already, but first we need to check for the appropriateness of the normal approximation. Alright, when I say check for, I mean check for the validity. So we have two conditions. One, n is in this case 500, which is why we're thinking of it. It's greater than 50, so that condition is held. The expected value of x, or the mean, np, 500 times 0.45 is equal to 500 times 0.45 is 225. Right, it was going to be large, but didn't know it was going to be that large. Is greater than 5. Alright, so that condition holds. Alright, so both conditions hold, so the normal approximation is good. Okay, so here we have our problem, and I'll just rewrite it. Probability of getting between 200 and 250 inclusive, with n of 500, p of 0.45. So this is our binomial. We can approximate to the normal now. It's approximately normal. Alright, we have our two limits. From the lower limit we go down a half, 199.5. To the upper limit we go up a half, and then we state the mean and standard deviation of the normal. The mean we already have is 225, standard deviation we don't. Standard deviation formula, square root of np times 1 minus p, okay, which is 225 times p of 0.45 times 1 minus p, 0.55. Don't forget the square root. Alright, equals the square root of n 500 times 0.45 times 0.55. There's 11.12. So back to our statement of the normal distribution. Alright, so now we have two limits, a mean and a standard deviation. Okay, and let's draw our diagram. So first, the distribution of x. Oops, that's not x there. It's x over here. The mean of that distribution is 225. Okay. The limits look to be symmetrical around the 225, and we'll find out in a second when we get our z values. 119.5 to 250.5. Okay. And as I said, we're going to whoops, straighten that up a little bit more. Translate that particular x down to the z distribution. We'll find the z values corresponding to these two limits. Okay. Alright, so that's the next step. Alright, so for the lower limit it'll be 119.5 minus the mean 225 divided by the standard deviation, if I remember, 11.12. Okay, so equals 119.5 minus 225, the mean, divided by the standard deviation, and that's negative 9.48. And then for the upper limit, z is equal to, I didn't write down my formula, so let's just do that just to make sure we all understand. X minus mu on sigma, x 250.5 in this case minus the mean of 225 divided by the standard deviation 11.12. Alright, 250.5 minus 225 divided by the standard deviation, and hardly symmetrical. 2.29. Just to make it a correction here, instead of editing the video, my first thought was correct, of course, and that is that the mean of 225 is halfway between 200 and 250. And it turns out that my first calculation for the calculation for my first limit here was wrong, and that's equal to minus 2.29. So, okay. So instead of making that look real pretty, I'll just scrub that out right now from negative 2.29 to a positive 2.29. Okay, and so that's our probability for the z. So the probability is approximated on the z to be between minus 2.29 and positive 2.29. Since this is a symmetrical area, all we have to do is to find 1 and multiply by 2, or add the two of them together. So a normal distribution going to 2.29. Okay, and that'll be 2.2 row last number 0.4890. So it's 2 times 0.4890, and it's 0.9780. Okay, and that's our probability. Very high, but not exactly 100% yet. Okay, of course, nothing is exactly 100%. Okay, and that's that problem. Let's now look at this problem. Again, if at this point you should try it yourself and then look at my answer.